Hello future engineers, viewers, subscribers, and students. Here is another video in statics about centroids and moment of inertia of plane areas. Now, this is intended for slow and weak engineering students. I hope that through this video, I can elevate those who will accept that you are slow or weak engineering students. Uplift, I can elevate your level. So here is the problem for the composite area shown. Determine Ix, B Igy, C K sub O, and D Igx. For part D, I will leave this to you. And if I present two ways to solve part B, then you also present part D into two ways. And that is for your own sake so that you can master calculations transferring moment of inertia with respect to another parallel axis. So here is the figure. So Ix is simply Ix of square 40 by 40 minus Ix of triangle. All these have ready-made formulas except for Ix of this quarter circle, which should be transferred to the x-axis from its centroidal moment of inertia with respect to x-axis to the x-axis. And the centroidal moment of inertia with respect to the x-axis of a quarter circle is half of that centroidal moment of inertia of a semicircle. So half of 0.1098 is 0.05488 r to the fourth. So Ix again is Ix of square minus Ix of triangle minus Ix of quarter circle, which must be transferred. By the way, the location of the centroid of a quarter circle from this upper end or radius or diameter is 4r over 3 pi. 4 times 20 divided by 3 pi is checked. You have to show that it is 8.4883 to 4 significant figures in mm. Then this distance of the centroid of the quarter circle to the x-axis is 40 minus 8.4883, so 31.5117. So that's also 31.5117. So Ix of square is 40 by 40 cube over 3 minus Ix of triangle 20 by 40 cube over 12, then minus quantity. So that's for square, this is for triangle, minus quantity 0.0548820 to the fourth plus area pi over 420 square, distance 31.5117 quantity square. So solving for Ix is equal to 42930 mm to the fourth. So take note, those students under me, that this is one of the problems I gave you in your quizzes, in one of the quizzes that I gave you. So next is IGY. So for IGY, let's solve for the location of the centroid of this area. And area is equal to area of square 40 square minus area of triangle 1/2 of 20 times 40 minus area of quarter circle pi over 420 square. So that's 1600 minus 400 minus 100 pi, or 885.841 mm square. By Varignon's theorem, we need xg to solve for IGY. And for my viewers, because of part D, I want you to solve for YG also, so that you will have two ways to solve for IGX for your part. So 885.841 times xg equals 1600 times 20 minus 400 times 1/3 of 20, location of centroid of triangle, minus 100 pi times 31.5117. So 20 is the centroidal x-coordinate of the square from the y-axis. Solving for xg, xg is equal to 21.938 mm. So let's locate the centroid of the area at G. So that's why this is 21.938. As I said, viewers should solve for YG to prepare for the calculations of IGX for your part. So having found XG, you can now compute IGY by transferring the moment of inertia of each individual areas to this centroidal axis. So the formula is centroidal moment of inertia with respect to the y-axis of each area plus area distance between the centroidal axis of individual area and the centroidal axis of the entire area. So in this case, for square, 20 times 40 times 40 cube over 12 plus area 1600, then 21.938 minus 20, the distance of the centroid of the square from the y-axis square. Then minus for the triangle, 20 times 40 cube over 36 plus area, which is 400. So minus quantity, that's minus quantity. 400, then distance is 21.938 minus, this is 20 over 3. So 21.938 minus 20 over 3 quantity square. So 20 cube 40 over 36 plus 400, then quantity 21.938 minus 20 over 3 quantity square, then minus for the quarter circle, we just copy this, except that the area is 100 pi. It's the same. So minus 0.05488 20 to the fourth plus 100 pi times 31.5117 minus 31.5117 minus 21.938. So that's the distance between the centroidal y-axis of the quarter circle and this entire area or net area. So calculating IGY equals 79593 mm to the fourth. So if your answer will differ by around 20, that's acceptable because of rounding of values. Next is KO. KO is the radius of gyration with respect to origin, or JO, IO, JO, IZ, that's the same. And it is equal to, IO is equal to IX plus IY. We already computed IX. We just compute IY. Then equate it to area KO square. So IY is IY of square, which is the same 40 cube 40 over 12 over 3 rather, minus IY of triangle 40 20 cube over 12, then minus we have to transfer moment of inertia of this quarter circle to the y-axis, so centroidal 0.05488 20 to the fourth plus area 100 pi, then 31.5117 square. Computing IY is equal to 55,930 mm to the fourth. So IO is area OKO square, and IO is IX plus IY, and it is equal to 425930 plus 505930 equals area, which is 885.841, then KO square. Solving for KO, square root of IO over area, and that is equal to 32.43 mm. So as I said, for your part, you have to show into two ways that IGX is 1085.69 mm to the fourth. So that's it for this video.